posted many different ways to solve it yesterday. Okay, so just to refresh on the problem, you've got these three cards, green, green, red, green, and red, red. You draw a card and see one of the faces and it's green. What is the probability that the other side is green? Okay, so basically to start thinking about coding this, it's fairly straightforward to model the initial drawing of the card by just coding the cards as 1, 2, and 3, sampling from 1, 2, and 3. So basically R is going to see something like this, and it's just going to randomly grab one of these based on the probabilities that you specify here. Okay, so I'm going to get 10,000 of these for the simulation, and what we'll get is initial draws will be a numeric vector that's going to look something like 1, 3, 2. This is just like hypothetically what it might look like. Okay, so now what I want to do is I want to examine each element of the sample with the intention of creating a new vector representing an outcome of the conditional probability implied by the card number. Now that might sound cumbersome, but really all I'm saying is like, look, if I've got card 1, well, my probability outcome, my like probability, conditional probability associated with card 1 is like just that it's automatically going to be green. So like 1 just maps to another 1, 3 maps to 0, 2 is the only one that's a little bit trickier because 2, the conditional probability is basically represented by a coin flip where like a 50-50 chance of having it be red or green when you pull out a card 2. So basically I'm just going to go through each element of this vector and appropriately map it to the probabilistic outcome implied by the card. And in the case of cards 1 and 3, it's not really a probabilistic outcome, it's a fixed outcome. Okay, let's move on to this guy. Okay, so here's my sort of idea for how to do it. What I wanted to do is use an if-else loop 2 times. So okay, so for this round, I want to ascertain whether it was like red or green. So I'm just going to code green as 1 and red as 0. So here's my initial draws vector, something like this. And basically what an if-else statement does is it takes your vector and it spits out a vector of equal length. And the way that it fills that second vector is it will look one by one at what's in your input vector. It'll test it against some condition that you give it, and then it will put into the new vector whatever you tell it. So this is like if the condition holds, it'll do this, and if the condition fails, it'll do this. So what I'm interested in is, okay, if my initial draws is equal to a 1, I want my new vector to get green, which I've coded as 1. And if not, then, or else, you could say, I want it to get a 0. So I would run this kind of thing, and just to show like what it converts into, if this was my initial draws, the 1 would map to a 1, everything that isn't 1 would get mapped to a 0. Okay, and then what I wanted to do is the same sort of thing for card 2. And so the idea, the key difference here is that, as I said for the last slide, what I would want this vector to get would be the result of a coin flip, or a one random variate from a binomial distribution of size 1 and equals 1 with probability of 0.5. And so, like, just to explain why we want to do that, you know, I would basically have these two vectors of 1s and 0s, and my idea is that if I could sum those up, I would get, okay, not sum them individually. If I added those vectors to one another, I would get a new sort of like mega vector of ones and zeros, where the ones represent the outcome of seeing green for both card 1, card 2, and card 3. Because obviously card 3 doesn't really enter into this because it's never going to be green. So like having just placeholder zeros basically takes care of the information that we would have gotten from explicitly including like a card 3 into this system here. Okay, but I'm going to tell you right now, this didn't work. It failed, it crashed and burned miserably. And the reason that happened is R got very upset about my asking it to put this random variate within an if-else statement. So what I had to do is construct like a proper loop, and then have an if statement within that loop where I went through like the proper syntax for doing an if-else loop, which isn't using how can I differentiate between an if-else loop and an if-else function call? Well, maybe that's why this is a bit confusing. But anyhow, this isn't how I did it, but once I did it, I went ahead and I created this new vector called show green, which was just the addition of these two vectors to create my mega vector of ones and zeros. Okay, well now what? So once we've got that critter, we're almost done. We just have to ask, of the total cards showing green, which is simply summing show green, what proportion came from card 1, which would just be, you know, the sum of card 1. Well, the proportion isn't this. Like, which ones came from card 1 would be the sum of card 1. So then you can state that the probability that you're going to flip and get green, which we know from working with this problem is essentially asking what is the probability that you're holding card 1, would just be the sum of card 1 over the sum of show green. Okay, so I've already sort of addressed this problem. Let's go see the code as I constructed it. So as promised, I've created initial draws sampling from 1 to 3. I've done my if-else function as I said I would, taking anything that's 1 and mapping it to a 1. Okay, and then here's how I actually did the same procedure for the second vector. Is ahead of time I created 10,000 random variates from a binomial distribution. I've created my card2 output, basically a slot in memory to hold what's coming in this loop. And then what I did is I looped through and I said, look, okay, if initial draws is a 2, well, I want that to map to something happening at card 2. And what I want it to do is to grab from my pool of random binomials. And, you know, it actually doesn't really matter where it's indexed. You know, if I could index it somewhere random, or if I could index it from like the back of the list to the front, or just like, you know, jumping amongst, say, like 20 random elements from the vector, that would still work. But I mean, it's just convenient to like have it go through your pool with the same indexing as it's going through for the card. It's just easy to code it that way. Okay, so we know that we're basically doing our coin flip if initial draws was a 2, and if not, our card 2 is just going to get a 0. Okay, as promised, we're adding the card 1 and card 2 vectors to get like a mega vector of 1s and 0s. and then the probability of flipping green being the sum of card 1 over the sum of showing green. And then I just want to print this. And if we recall from the last video, we so desperately want this number to be 2/3 or 0.666 dot 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 and not a half. So we're gonna run the code and, like, you know, hope that we've met this expectation. Yay! And we see we get 0.66099. Do it again. 0.566. So we're getting things that are very close, or to me, close enough to 0.66 that I'm convinced that we've coded the problem right and done an apt simulation. All right, thank you very much, everybody, and have a terrific Saturday, September 21st. Peace.